Hello, so I've been given a diagram with some angles and some lines on, and I've been given some information before I've actually been asked a question. So it makes sense then, rather than just skipping straight to the question, to actually refer this information back to the diagram, just so I've got in my head what's actually going on. So I've been told that AE, DBG and CF are parallel. So there's AE, there's DBG and there's CF, and they're all parallel. Yeah, that looks about right. I'm happy with that. I've then been told that DA is equal to DB is equal to DC. Well, there's DA, there's DB, and there's DC. So they're all equal. Yeah, that looks about right. I'm happy with that. And then I've been told that angle EAB. So what is angle EAB? Well, angle EAB, I first of all find E, I then join it to A. So there's A, and I join it there. Okay, I then look at the second two of the three. So I look at the A and I look at the B and I join those 2 points together. So there's A, there's B, and I join those 2 points together. And the angle between those two lines is the angle which I'm interested in. So there's my angle. There's my angle which is EAB. Okay, and I've been told that is equal to angle BCF. So I do exactly the same thing. I find B, I find C, and I find F, and I work from left to right. So first of all, I pair B and C together. Okay, then I pair C and F together, like that. And the angle between those two lines is that angle there. So there's my other angle, and I've been told that those two angles are equal, and they're equal to 38 degrees. So this angle up here is equal to this angle down here. I've then been asked to work out the size of angle marked X. So this is the angle marked X, this is the angle I'm trying to find, and I've been asked to show my working. Okay, well, first things first, I know from the alternate segment theorem, that when I have a Z shape like that, so this line is parallel to this line, I know that that angle in there, must be equal to that angle in there. So look, are you happy then? This is just a reverse Z shape. It's exactly the same thing, but it's just in reverse, if you like. So this is this, just flip round the other way. So I know then that this angle up here, this 38 degrees, must be equal to this angle down here. So I know then, so what is that angle? It is angle ABD. Angle ABD. Because I'm joining the A and B together, and I'm joining the B and D together, and I'm forming the angle between those two lines. So angle ABD must be equal to 38 degrees. Okay, good. I then know that this line is equal to this line here. And it's forming a triangle with this line here. Let me just draw that a little bit better. It's forming a triangle with this line here. So if this is isosceles with this side equal to this side here, I know then that this angle must also be the same as this angle down here. So in other words, I know this angle here must be 38 degrees. I know this angle here must be 38 degrees. So I can say that because triangle, I can just use triangle notation like that. And it's triangle ABD is isosceles. Careful how you're spelling isosceles. Then angle, what's the angle? Well, it's angle it's angle DAB. Angle DAB must also be equal to 38 degrees. Okay, so therefore I know that angles in a triangle must add up to 180 degrees. So I can say that angles in a triangle add up to 180 degrees. So therefore I can say that I've got two angles being 38 degrees, so the third angle must be 180, so the third angle must be 180 minus 38 times 2, which I think comes out as 104. So that is angle, what angle is that? That's angle, this angle here, so it's angle ADB. So angle ADB equals 104 degrees. Okay, and actually it's just a case of repeating exactly the same. So this angle in here is 104 degrees. And actually I can repeat exactly the same logic down here, because I've got exactly the same segment theorem, It's the alternate segment theorem, which tells me that this angle must be the same as this angle here, so I know that this angle must be 38 degrees. And therefore, I can use the same logic because this is also an isosceles triangle, which tells me that this angle must be the same as this angle. This angle is also 38 degrees. I know that angles in a triangle must add up to 180 degrees, so I know that this angle here is 104 degrees. So therefore, I can then say, if I get rid of everything else, I can then say that angles round a point add up to 360 degrees. So I know that angle X then must be 360 minus 104 minus 104. So angle X must be equal to 360 minus 104 times 2, which comes out as 152 degrees. So there's my angle X.